Hi there, I'm Hao, and this is just another video of me solving random numerical problem. So binary tree, right side view. So we need to return the view, the right side view of a binary tree, right? So if we have a tree like this, right? The right side view gonna at each level gonna be 1, 3, and 4. What if we have a tree like this, 1, right, 2, 3, and then let's say this is 5. So our right side view gonna be 1 at level 0, right, 3. Right? And then all the way here, which is 5. So it's not necessarily on the right subtree here, right? It is the first element we see on the right. So that is very straightforward there. We can just use a reference search, right? At each level, right, we can keep track of the elements, right? You can have our levels right here, right, at each level. So we have 3 levels in this case. Let's say assuming we don't have this number, right? So we have 3 levels, 0, 1, and 2, right? 1 and 2. And then we first push in the first level, right, which is 1, 0 here. Right, our level, right, current level gonna be 0. Right, look at the peak, current level is 0, and the current length. Okay, so our current length gonna be 1, right? So we only iterate over 1. So the logic is that we just iterate over every single element on the current level, right? On the current level, and whichever element we reach last gonna be the the one on our right side view, right? So we just iterate over the whole thing, right? One time. So we pop it off, right? We also had to set our last element, right? When we pop this off, we're gonna set our last element to be gonna be 1, right? And then we are done. And the element at the right side view on the first level, right? On level 0, gonna be 1. Okay, that's pretty straightforward. Okay, and now when we pop it up, right, we also need to add in the elements, right? If it has a left and the right child. So, and we also keep track of the level. The level is now be 1 and 3 and 1. Okay, so now our current length gonna be 2. So iterate 2 times, and then the current level now is 1, right? 1, 1, right? Just the peak is 1. Okay, so after we pop it off, so we pop up first one, which is the last element, become 2, right? And then when we pop it off, we need to add in the right child, right? Because we have a right child. So this become 5, right? And then level 2, right? Okay, so we continue. We have to iterate 2 times, right? So we need to go one more. The next one gonna be 3. So our last element becomes 3, right? Right. And 3 doesn't have any element, so it's 5. Okay, so now we're finished. So our right side is gonna be 3, right? So on the last level, so next now the current level is 1, right? The current level is 2, right? 2. The peak is 2. So we pop it off, right? So now our element is our last element gonna be 5 here, right? And it doesn't have any left and right child, so we're done, right? So we set it to 5. And if we have 4 here, right? If we have 4, here, right? Then we will have 4 at level 2, right? So we pop this off, and the last element will be from 4, right? So on and so forth. So we just have to stop at the last element there, right? We just as we're iterating from left to right, it has to be from left to right. As we're iterating from left to right, we will keep track of the last element, right? Whichever element we reach last on that level will be our last element, our right side view element on that level. Okay. So we have a built-in queue here. We have a custom queue here, so we can have a shift, 1. the number of node can be zero, right? So that is a special case. If it have no node, we can just return an empty array. Right. We need our levels here on our queue. My queue. We need to push in the root there. And at level 0, we want to return the level at the end. So y do not length. Okay, then we need to look at the current level, right? We need to keep track of the current level, which is bit of tick, remember? And then we need to track of the current length equal to field length. Okay, and the last element, of course, turns out to be no. So for let I equal to 0, less than current length, plus length. So our node and level will be field of up. And we just set our last element equal to the current element, right? Which is node dot val. So the last element that we're gonna retry at the for loop gonna be the element. Okay, and then we're gonna do if node dot left, and we're gonna push right in the left child node dot left, and then level plus one, the next level. Similarly to the right. At the end, we need to set the levels at the current level, right, to be the last element. And yeah, that's pretty much it. And thank you for watching.